Now let's start the chapter on the flow in pipes. And the very first topic that we are going to do is the calculation of head loss due to friction in pipes. We have derived these equations. So the very first equation that we have is the Darcy-Weisbach equation. Darcy-Weisbach equation. The Darcy-Weisbach equation says that the head loss due to friction in a pipe flow is equal to 4F L V square upon 2 into G into D, where F is the friction factor, L is the length of the pipe, V is the velocity of the flow in the pipe, G is the gravity, and D is the diameter of the pipe. So this friction factor, it depends upon the Reynolds number basically. So you can say that F is equal to 16 upon Re if the flow is laminar, then it means it is viscous, and the friction factor is 0.0791 upon Re to the power 1 by 4 if the Reynolds number is more than 4000, which is turbulent. Okay, so this is the formula given by the Darcy-Weisbach to calculate the head loss due to friction in a pipe flow. The second formula is the Chezy's formula. So Chezy's formula says that the head loss due to friction is equal to F dash upon rho g into P by A into L into V square. Now what is this F dash? F dash was the frictional resistance per unit area per unit velocity. Okay, so I can do a little bit of manipulation in this. So this P over here, P is the wetted perimeter, and if I divide the cross section area by P, we get a value which is small m, and small m is called hydraulic radius. This is called hydraulic radius. Okay, so I can substitute this value over here. So HF is equal to F dash into or upon rho g into 1 upon m into L into V square. Let's find the value for V square. So I'll have V square is equal to HF into rho g upon F dash into m upon L. Okay, so this is what you get. So HF into rho g, m goes up, F dash and L come down. Okay, let's take the square root of this. You can take the square root of this. Okay, so when you take the square root, let's group this part, and then you can group these factors as well. So you will get under root rho g upon F dash into under root h into m into L upon L. So you will get m into HF upon L. Okay, this term over here, this can be put as a constant because rho is a constant, g is a constant, and F dash would also be a constant. So this is called Chezy's constant. Okay, so capital C, which is under root rho g upon F dash, this is called Chezy's constant. Okay, and if I take this ratio, which is HF by L, this is the friction head loss per unit length. So HF upon L can be substituted as, let us say, letter I. So that entire equation will become C. This is the C part, okay. Into under root you will have M, and then HF upon L will become I. So this is another form of writing the Chezy's formula. So if you get this kind of an equation in the exam, you should be able to remember or recall that C over here is the Chezy's formula, the Chezy's constant, whose value is under root rho g by F dash, and I over here is the friction head loss per unit length of the pipe. So this is how you calculate the friction head losses in pipe flow by these two formulas. Now after this, let's start looking at some numericals on these two concepts.